All right, geometry, section 2-2, logic. And so now usually in the videos I'm writing all of this down, but there's so much writing here, I'd rather just talk through it and you can just pause as you need to and write down what is here. So I'm going to use my pencil so you can see as much as you can, and I can talk through it while you write down what's happening. So there might be some stuff that we write in a bit. So 2-2 is logic. So there's a lot of writing here, and so go ahead and pause as you need to. So a statement is a sentence that is either true or false. So you make a statement, the statement is either true or false. Statements are represented by P or Q. So I might have a statement that is P, or I might have a statement that is true, and the truth value is T or F, true or false. So I might make a statement P. Here's my statement, and my statement is statement P. A rectangle is a quadrilateral, and that's my statement. A rectangle is a quadrilateral. And my truth value is true. A rectangle is a quadrilateral. All right? Now, a negation is a statement that has opposite meaning as well as opposite truth value, represented by this squiggly line P or the squiggly line Q. The squiggly line means not. So when you see the squiggly line, means not. So I've got my first statement here, which is P. A rectangle is a quadrilateral, and my truth value is T, it's true. Now, not P, a rectangle is not a quadrilateral, and now my truth value is false, because a rectangle is a quadrilateral. So I've got my first statement, P, a rectangle is a quadrilateral, and then my negation, or my not P, a rectangle is not a quadrilateral. Notice how this one is false and the first one is true. Let's do, let's keep going through here, and then we can do some examples. Two or more statements joined by and or form a compound statement. So and is this almost a triangle that's pointed up, and then or is pointed down. So we're gonna look at all this stuff here coming up. And compound statement is a conjunction. So if you have an and compound statement, it's a conjunction. So here, and is going to be a conjunction. Okay, I'm giving you a second to you can pause here. It's a good time to write everything down. Okay, let's move on to these examples. So here are my statements, P, Q, and R. R can be a statement as well. P, the figure is a triangle. Here's this figure, it's a triangle. True, right? The figure has two congruent sides. Here's one side that's congruent to this side. Two congruent sides. Q, statement Q, is also true. Now R here, the figure has three acute angles. Now R, the figure has three acute angles. The figure has one acute angle and another one, so that's two. But this 90-degree angle is not acute. It's a right angle, 90 degrees, not acute, not obtuse, it's 90 degrees. So the truth value for R would be false. P is true, Q is true, R is false. Now let's look at what we're doing here. We're going to do some truth statements here, and we're going to look at these. We're going to make compound statements. So P and R. So remember, if it's up like this, it's and. So P, the figure is a triangle, and the figure has three acute angles. The figure is a triangle, and the figure has three acute angles. This is a false statement. The first part is true, but the second part is false, and since it's an and statement, the whole thing is false. Let's look at another one. Q and not R. Okay, so let's write those down. Q, the figure has two congruent sides. The figure has two congruent sides, and we have this and. The figure does not have, so we did the negation of R, does not have three acute angles. This is going to be true because R by itself was false, but not R is true. The figure does not have three acute angles. So Q and not R is true. Let's do this U-try together here. So P and Q. So P is, the figure is a triangle. Oh, so actually, you go ahead and do this U-try, go ahead and pause, and then come back and we'll do it together. All right, let's see how you did. P is, the figure is a triangle. We're true so far. Figure is a triangle. And Q, which is the figure has two congruent sides. So I've got P and Q. Those are both true statements. Oops, P and, oh gosh. P and Q is true because those are both true statements, and there we go. Good. Let's see what else is here. Or compound statements. So this is a disjunction. So if we have an and compound statement, that's a conjunction. An or compound statement is a disjunction. Okay, so let's do some, let's look at these statements. So P, January is a fall month. That's not true, right? January is a winter month. January is a fall month, so that's going to be false. January has only 30 days. That was also false, right? January has 31 days. January 1st is the first day of a new year. That one's true. So we've got false, false, true. P is false, Q is false, R is true. Okay, so now let's look at these together here. So Q is January has only 30 days. So Q, that one is false. Or R is true. January is the first day of a new year. January 1st is the first day of the new year. So since this is an or statement, I only need one to be true for the whole statement to be true. Because just one of them, it can be January is a fall month, or it has, January 1st is the first day of the month. If one of them is true, then a conjunction or disjunction, the whole thing is going to be true. All right, let's try another one. This one's going to be false, as you can see right here. Q, that one's false. Not R. Remember, R was true, but this time it's not R. So these are both false. So that's why we get a false truth value for this statement, this compound statement, which is a disjunction. Now, let's look at this truth table down here. We've got a few truth tables. So these are just some examples. So if P is true, or if P is false, and if we're going to start like this. Here's P true and P false. So that means not P would be false. If P is true, then not P is false. If P is false, then not P is true. That's how that works. All right. Now, in a conjunction, if P is true and Q is true, then P and Q are true. If P is true and Q is false, then P and Q is false. So remember, we're talking about and here. If P is false and Q is true, then P and Q false again. Only one of these need to be false in a conjunction for the whole statement to be false. Now, if they're both false, the whole thing is false still. Now, in a disjunction or an or statement, if P is true and Q is true, the whole thing's true. If P is true and Q is false, remember, only one of them needs to be true in an or statement. The statement is true. Again, if P is false, Q is true. It's an or statement, so the statement is still true. And if they're both false, then it's going to be false. And that is, let's see. Yeah. Let's do a U try here. Yeah, let's do it down here. Let's actually do it right here. All right, P, a three-sided polygon is a triangle. Q, a square is a four-sided polygon. And R, a hexagon, has 6 sides. Okay, so we can agree a three-sided polygon is a triangle. A square is a four-sided polygon. That's true. And a hexagon has 6 sides. Also true. All right, these statements are all true. Okay, now if I have Q and R, is this statement true or false? Q and R, they're both true, and statement true. If I have P and, and not R, is it true or false? P and not R. So, if I have the and statement, they both have to be true for the whole statement to be true. Since R is true, not R is false. So I've got a true one here and a false one here. Since it's and, this whole thing is false. Q or R. Okay. Q is true. R is true. So it's true. I'm going to have you guys do 2 more without me. Q and not Q or not R, and not P and not Q. Okay, do those 2, and then we'll talk about it in just a minute. Okay, pause, go. All right. Q is true, not R is false. One is true, one is false, and we're talking about or here, so only one needs to be true to have a true statement. Not P is false, not Q is false, and it doesn't really matter if it's and or. False and false is going to give me false. And that is Geometry 2-2 Logic. Do a good job on your homework.